class. I know, that's dumb. Oh, hey, I didn't see you there. Would you like to learn how to balance some redox reactions with me? Well, we'll begin with an acidic reaction. What you first want to do to balance this is split it into two half reactions, one with the oxidation and the reduction half. To begin balancing, you first focus on the elements that aren't oxygen or hydrogen. As you can see in the oxidation half, this would be chromium. To begin balancing this, we add a coefficient of 2 to this side. To begin balancing the oxygen in the oxidation half, we then have to add water to this side to balance out the oxygen in the reactant side. Because there's because there's a subscript of 7 on the oxidation, we have to add a coefficient of 7. Now we have to balance out the hydrogens that was added in with the water. Because there's 14 hydrogens on this side, we have to add 14 hydrogens over there. The added hydrogens created an unbalance in the charge, and we now have to balance that out. To do that, we have to add electrons to the equation. To balance the electrons in this equation, we have to add 6. Now we'll move on to the reduction half. We see that the coefficients of the non-oxygen and hydrogen elements are already balanced. So to balance out the oxygens, we add water to this side. We see again that there's more hydrogens on this side than there's on that side, so we have to add hydrogens to the product side. Again, there's an unequal charge in this equation, so we have to add electrons to balance it out. We will add 6 electrons. Now that we have balanced out the half reactions, we have to put them all together and then balance the entire thing out. Wait, can you pause it? 1. That was hard work. So, we have the entire reaction written down here, but it's technically not still balanced. So in order to do that, we have to balance out the charges first. Right now, because we have 6 charge on this side and 6 charge on that side, the charges are now balanced. So we could just erase that. Now we have to balance out the waters. Because there's 3 waters on this side and 3 waters on this side, we'll change this to 4, and this will be taken away. Now, we balance out the hydrogens. There's 14 hydrogens on this side and 6 on this side. To balance it, we'll take 6 from the 14. And 6 from this side. Now our reaction is balanced. Wow, that was some hard work. Now we're going to begin on a basic solution. I have already split it up to its half reactions, the oxidation and reduction reaction, and because the non-oxygen hydrogen elements are already balanced, we don't need to balance those. We're going to now balance the oxygen and the oxidation half. To do that, we're going to add 2 waters. Because there is now hydrogen that is unbalanced, we're going to add 4 hydrogen to the other side. Now that we did that, we now have to balance the charge in the equation. Because there's a charge of 3 on this side but not on this side, we have to add 3 electrons. Now this is where the reduction reaction. We're going to begin by balancing the oxygen. Now that we balanced the oxygen, we will go to adding 6 hydrogens to balance on the other side, to balance out the hydrogens we added on this side. There is now an uneven charge. To even out the charge, we have to add a charge of 6 to this side. We will now go to adding the hydroxides to even out the hydrogen in this half reaction as well.
Hey guys, experienced some technical difficulties. I know you might have seen some hydroxides on the oxidation half reaction. We will now delve into that. Don't worry, you didn't miss a step. I'm addressing that now. So in basic balancing half reactions, you need to add hydroxides to both sides of the equation to neutralize the hydrogen. You add the same number of hydroxides as the number of hydrogen ions. That's why I have a 4 coefficient in front of the hydroxide ions. In the reduction, I'm putting a 6 coefficient because there are 6 hydrogen ions in the reduction half reaction. Now we see that we have a hydroxide and a hydrogen ion on the same side. Now when they are on the same side, we want to erase that, and they will be turned into 6 waters. The coefficient of the waters will be the same number as the hydroxide ions and the hydrogen ions. We're going to do this to the reduction side, but we're also going to balance this further by taking the 3 away from the reactant side and the 3 away from the product side to show an excess. We're going to do the same step to the oxidation, where we combine the hydroxide and hydrogen ions to make 4 waters, and then we'll subtract the 2 waters from the product side and 2 waters from the reactant side. There's another step that we didn't do the acidic reaction that we'll have to do in this reaction. As you can see, the charges aren't balanced. We have 3 electrons in the oxidation half reaction and 6 electrons in the reduction half reaction. This means that the charges aren't balanced. In order to do this, we will multiply the lesser electron number by the ratio that the numbers are at. So we have a 3 to 6 ratio, that's 2 to 1. So we have to multiply the oxidation half reaction by 2. We will now take the 2 half reactions and combine it to 1 full reaction and then continue to balance that. This is the full reaction for this problem. We will begin to balance this reaction by taking the 6 electrons away from both sides. To continue to balance this reaction, we must take away the 3 waters from the product side and 3 waters from the reactant side. Next, we have to balance out the hydroxides. To do this, we must subtract the 6 hydroxides from the reactants from the 8 hydroxide in the products. The equation now will be fully balanced. This is the acidic problem that you will now try. Feel free to pause the video and then come back for the answer. This is the unbalanced form of the equation. Your answer will be H2I2 5OCl equals 2IO3 2H and 5Cl. If your answer isn't that, you did it wrong. This is the basic equation that you will now try. Take a minute and pause the video to try this for yourself. The answer to the basic equation. At the very bottom, you'll find the balanced form of the answer. If your answer doesn't look like this, please see it again. You're wrong.